Science is an ongoing process. Ideally, new scientific studies build on the results of previous studies, gradually forming the evidence base that supports future studies. Publication is a central part of the practice of science, because the only science that we know about is the science that gets published. The quality of published studies is vital. Across scientific disciplines, the current evidence base forms the starting point from which researchers design new studies. Therefore, it is important for every researcher to be aware of several biases that could distort an evidence base. In medicine, the best available evidence not only influences researchers, but also the decisions policymakers and health professionals make about medical treatments for patients. In this animation, we use clinical trials in the field of medicine to illustrate the impact of 4 major forms of bias. The size and significance of an effect, for instance the effectiveness of a treatment, can be estimated by combining the results from multiple similar studies in a meta-analysis. The first set of biases that can distort an evidence base directly impacts on these effect estimates. When studies with statistically significant findings are more likely to be published than studies with non-significant findings, it is called study publication bias. It has been estimated that as many as half of all clinical trials are never published. If studies that do not find evidence for a certain treatment effect do not appear in the published literature, then effect estimates will be distorted, leading to an overestimation of treatment effectiveness. Clinical studies should specify in advance the primary outcome measure that will be used for evaluating a treatment. When the non-significant primary outcome is not reported in the resulting publication, or replaced with another outcome that was statistically significant, it is called outcome reporting bias. If, in the published article, the original primary outcome of a study is replaced by a more positive one, this again leads to an overestimation of treatment effectiveness. There is also a second set of biases, which does not directly distort effect estimates, but impacts on the apparent effectiveness of treatments. These biases can make treatments seem more effective than is justified by the strength of the evidence. Studies with accurately reported non-significant results on the primary outcome will contribute important effect estimates for use in meta-analyses. But the presentation of results can still influence how positively readers perceive the study to be. The use of reporting strategies that, intentionally or unintentionally, emphasize positive findings while downplaying non-significant findings on the primary outcome is called spin, or selective focus. Spin can make the published literature seem more convincing than warranted. Citations to an article determine how visible that study is in the evidence base. Citation bias occurs when statistically significant studies are cited more frequently than non-significant studies. A disproportionate number of citations to positive studies leads to studies with non-significant results being less visible. This distorts the apparent effectiveness of a treatment. In medicine, policymakers and health professionals need to be aware of these biases to be able to evaluate the evidence base accurately. Researchers need to be aware of potential distortions in the evidence base to prevent false assumptions and research waste. These biases are unlikely unique to clinical trials in the field of medicine. What is the situation like in your field of research?